Hey, sorry for making you wait. I was busy removing some configuration files out there, but here I am. Today, I'm here to tell you about NX implicit libraries. If you're not familiar with NX, NX is an open source build system, but I prefer to call it a progressive build companion. Whether you're using a monorepo or not, NX will help you optimize your development workflow and let you focus on the areas where you excel so that you can deliver value. Also, you don't have to go all in. You can progressively cherry pick the NX features you want. In order to leverage all the benefits of NX, it is common to split apps into smaller libraries. This way, and without much effort thanks to NX features like agents, caching, and the dependency graph, you can skip executing some tasks when it's not necessary. For instance, why would you run tests when the tests or the system under test didn't change since the last time we ran the tests? Why would we redeploy an application if nothing affecting the application changed since the last deploy? This will also simplify parallelization or enforce a good separation of concerns thanks to clear boundaries. Now, let's zoom in on one of these libraries. You'll often notice a couple of configuration files there, like NX configuration file itself, the projects.json file. This file is what defines the library. It has a special field called targets that defines the tasks you can run on this library, like linting or testing. Luckily, since NX 18 and Project Crystal, some targets are automatically inferred from your workspace structure thanks to plugins. For instance, assuming that the right plugins are enabled in the NX.json file, if NX finds an ESLint file round or a vtest config file round, it will respectively add the lint and test targets to the library. Now, you might have noticed that the remaining information in project.json file can be guessed from the workspace structure, assuming that you have a strong and explicit naming convention. What if we could totally get rid of project.json and infer all the information in it? Then, while we're at it, you will also generally notice that the other configuration files are often similar between libraries, so why don't we use shared configuration files? This way, the only thing that would define a library is that it follows a given workspace structure convention and it has an index.ts file at its root. Let's assume the following workspace structure with only one project.json in the application. By default, NX will only detect the application as it has a project.json file, and this is how the graph would look like. Thanks to Project Crystal or NX Inference, you can create your own plugin that enriches the graph. For instance, you can add the libraries to the graph whenever you match an index.ts file in the Libs folder. Once you activate your plugin in the NX.json file, NX will discover these libraries just as if they had a project.json file. Now, how does that exactly work? Once you declare your plugin, whenever NX decides to update the graph, it will call your plugin with an array of all the files matching the pattern you provide. Then, you are free to parse these paths and browse the workspace to decide how you want to extend the NX graph. In this example, we are computing the project name from the path and adding it to the graph. Next, you can add the targets you want with the options of your choice. In this example, we can now lint and test these libraries. Finally, we can derive the tags that will help us later enforcing boundaries or filtering tasks to run. So, this is how a simple implicit library plugin could look like. Even though these projects are inferred, you can still view the project information and targets in the NX console or using the NX graph view. And this is how your workspace goes from lots of duplicated configurations to way less configuration files. Now let's watch this in action. Okay. Initially, I just have two libraries with an index.ts in them. But I didn't enable any plugin yet. So let's look how the graph looks like. It is empty. So let's enable our implicit libraries plugin. As I added a plugin to the NX.json config, I have to reset the NX daemon and open the graph again. Great, my two libraries are here, they have the right name, and if I jump to the detail view, I can see that they have the right name, the right tags, the right targets, and everything. Now, let's create a new library by creating an index.ts at the right place and see what happens. And our library is here. Let's now import something from the catalog UI library. The NX graph is updated accordingly. Now let's try something else. Let's create a cart infrastructure library and try to import the UI library from the infrastructure library. This is not allowed by our architecture style and the rules that we enforced in the ESLint config. So let's see what happens. And we have an ESLint error because we're not allowed to import a UI library from here. Now, let's try and run all the tests. Interestingly, it's only running tests for the catalog UI and cart UI libraries. But that's just because in our plugin, we don't add a test target if there are no tests. So let's add a test to one of our new libraries and see what happens. Let's run the tests. And the new target is there and it's working. If you want to learn more about NX implicit libraries, or if you're looking for more NX recipes and spicy ingredients, check out the Marmy Code cookbook. Thank you for watching and see you soon.